All right, you mathematical mavens. This is our last week of division practice, so we really want to push to make sure that we feel comfortable with long division in general and division that involves decimals in particular. So on 5-9, there's a mix of problems. Some have decimals in the divisor, some have decimals in the dividend, some have decimals in both, and there's one or two problems that are just whole number division problems. So nothing new this week, we're just practicing for fluency and accuracy. All right, so let's take a look at a few example problems. Here we have problem 2, and it says, well, we've got 24 of something, and we want to know how many groups of 6/10 we can get out of it. Aha! There's a decimal in the dividend. We must create an equivalent problem where there is no decimal in the dividend, because that is just going to be confusing. So if I've got 6/100 here, I think I might have said 6/10 earlier. I meant 6/100. If I've got 6/100 here and I want this to be a whole number, which would be 6, how do I get there? I multiply it by 100. When I do that, that 6 skips 2 places to the left, goes to the ones place. If I do this to the divisor, I must do the same thing to the dividend. And 24 times 100 is 2,400. And here we have kind of a standard 4th grade problem now. Decimals gone. Whatever quotient we get here would be the same quotient we would have gotten from our original problem. I can get no groups of 6 out of 2, but I can get how many? Oh yeah, 4 groups of 6 out of 24. In fact, that's all 24. And I can bring down the next 2 zeros, and you might be thinking, well, okay, we're done. Except for we know 6 times 4 isn't 2,400. And we know if the 4 is in the hundreds place, we need to have something in the tens and something in the ones to show this is a hundreds number. Since there are no groups per se that are tens or ones, that means this problem has 2 placeholder zeros. Now 6 times 400 is 2,400. Problem solved. All right, let's take a look at a problem a little more complex. So here we've got 5 and 148 thousandths, and for some bizarre reason, we want to know how many groups of 33 thousandths we could get out of that. Well, again, this is a job for an equivalent divisor and dividend pair. I do not want a divisor that is a decimal. Too confusing. So, off I go to the races. If I have 33 thousandths, I want that 33 to be a whole number. To do that, I need those digits to move 1, 2, 3 places to the left. That's times 10 times 10 times 10, or times 1,000. Whoop, boop, boop. 33. If that part's confusing you, remember, you can always, somebody's getting a phone call. There we go, problem solved. If that part is a little confusing for you, check your multiplication with a calculator to make sure you're on the right track. Now, if I multiply the divisor by 1,000, I have to do the exact same thing to the dividend if I'm creating kind of an equivalency. So, when I multiply 5 and 148 thousandths by 1,000, again, these digits are all going to scooch 1, 2, 3 places to the left. So in this case, we have another problem where conveniently our multiplication has kind of swept the decimals aside. All right, so from there, we need to figure out how many groups of 33 we can get out of the dividend. Oh, I'm going to need a thinking number, so I'm going to round to 30. If I know my threes, then I know my 30s times 10 times 10 times 10 right down the line. And I can use this for estimation. Can I use it for calculation? Au contraire, mon frère. I've got to remember My actual divisor is 33, and that's the one that I want to be prepared to use when I'm making my calculations. Okay, how many groups of 33 can I make out of 5? Not one. How many out of 51? Well, just one. I don't even have to estimate on that one. And I know 1 times 3 is 33. And I can do some subtraction here. It turns out it's 18. Feel free to do that on the side for yourself, especially if you're like, how can that be 18? We'll check it on the side. I can't make any groups of 33 out of 18, so it's time to bring down that next digit. I can out of 184, but I don't really know off the top of my head how many. This is where my estimation comes in. So how many groups of 30 gets as close to 184 as I can get? Whoa, looks like it's maybe gonna be what? Oops, I messed up over here, didn't I? Hey, I bet some of you were yelling at your computer and saying, lady, you forgot something. Because I most certainly did forget something. 3, 6, 9, 12, 15. I forgot. Kind of an important one for this, didn't I? There we go. Now things look much better. All right. So maybe I could get 6 groups, although I have a feeling it's going to be a little too much. But I'm going to try it. 6, 12, 18, carry the 1, 18, 19. Yeah, 198 is too much. If 6 is a little too much, I bring it down to 1 group less and try 5. 15, carry the 1. 15 times 3 is 15 plus 1, 16. That looks like it will work just fine. So I've grouped 165 of that 184. And again, if I need to, hopefully I've got some space where I'm sort of doing some of this sloppy calculation because I want to get it right. And just guessing on the subtraction when I'm not 100% sure isn't going to feel very right. All right, 19's what's left. Not enough to make a group. Time to bring down the next digit. 198. Oh, hey, I already did that problem. I could go through the estimating and stuff, but I can literally see it right there. I can see that 6 groups of 33 is 198, leaving me with, thankfully, no remainder. Good news for us. All right. Let's bring it into the home stretch. Okay, so here we have problem 15. It talks about the area of the room, and it already tells us the square footage is 114 square feet. Then it gives us one of the dimensions that creates that. It tells us the length of the room is 9.5 feet. If we want to know the width, just a quick reminder, when we know that the area of a rectangular room like this is going to be length times width, if I already know the product or the area, and I already know one of the factors, the length, then the way I find the missing factor is by dividing the product by one of the factors. This goes all the way back to 3rd grade as a concept, and we'll just keep on coming at you really for the rest of your life. Area is for real. Okay, so if I want to know that missing factor, I've got to do this division, and I see there's the decimal in the divisor. What are we going to do? Hopefully, you're going to pause here, and you're going to try to figure that out. You're going to think about, well, what do I do with that decimal? How do I create an equivalent division problem, right? Now, let's see how far you got and where I can help out. So if my problem is 9 5/10, I need all of that to become 95. How do I do that? I have to multiply it by 10, because when I multiply this number by 10, each of these digits moves one place to the left, and 9 5/10 times 10 is 95. If I'm gonna do that for the divisor, I must do the same to the dividend. You might be thinking, but there's no decimal. Sure there is. The decimal is always to the right of the ones place. 114 times 10 means everything moves over to the left one. So now there's a 0. 114 times 10, 1,140. Okay, so here we have a standard 5th grade division problem. And I can use 100 as my estimation number, and I'm going to live life on the edge. I'm not going to make an estimation chart because I can skip count by hundreds pretty quickly, and I bet you can too. Let's see how we do. How many groups of 95 out of 1? None. How about 11? Nuh-uh. How about 114? Well, only 1. I don't even have to use an estimation chart. I know I can't get 2 groups of 95 because that's going to be way more than 114. Now, I don't like to make my main problem too messy, especially if I'm going to have to ungroup and regroup because it's just hard to read over there. 14 take away 5 is 9. 10 take away 9 is 1. So I got 19 left here, and I can't make any groups until I bring down the next digit. How many groups of 190 can I make out of 95? Well, it's either going to be 1 or 2. Well, I already know 95 times 1. Let's see what 95 times 2 is. 2 times 5 is 10. Carry the 1. 2 times 9 is 18. Plus 1, hey, is 19. And that is that, my friends. So, what is the answer to the question, what is the width of the room? Well, division tells us this room is 12 feet. No, it is not 12 square feet because square footage is area, not just one dimension, in this case, width. 12 feet indeed. All right, hopefully this has been a good reminder for you and you took the time to pause the video and try problems on your own. Trying them on your own and then checking your work, maybe with a calculator. Maybe you wait for the answer key, but a calculator can really kind of tell you right away. Will help you stay on track and sharpen your skills. You can do this because whoever does the work gets the benefit.